In this lesson, we're going to talk about how we graph logarithmic functions. Yesterday, we spent time graphing exponential functions. Today, we're going to apply transformations to logarithmic functions. But first, we're going to talk about the properties of parent log functions. So parent log functions, all of them have vertical asymptotes. And all log functions have vertical asymptotes. The parent would have one at y equals 0. Or at x equals 0, x equals 0. And so the range, or that actually restricts the domain because we have a vertical asymptote and not a horizontal asymptote. So for the parent function, the domain is x is greater than 0. And that ties back to our log function. X is the argument, and we know that an argument cannot be 0 or negative. The range for a logarithmic function is all reals. There's no value of y. Since y is the exponent, there's no value of y that I can substitute in that creates any kind of issue. The restriction is in the domain. Finally, the two critical points in the graph of the parent log function would be 1, 0. We cross the x-axis at 1, and b1, where b is the base. So if I move to the right the value of the base, my y value will be 1. So these are the particular properties that we are going to use when we apply transformations to log functions. So let's just first graph a parent function as a refresher from what we did in the previous unit. Y is equal to log to the base 3 of x. This is a parent function. Its base is 3. Its argument is x. So I know for log functions I'm going to have a vertical asymptote on the y-axis. And I know the point 1, 0 is on the graph. And the point 3, 1 is on the graph because that's the base. And now remember, my graph does not terminate. We have arrows on both ends, and there's only a vertical asymptote, not a horizontal. So that's what my graph looks like. Y is equal to log to the base 3 of x. The domain is going to be x is greater than 0, and the range is going to be all reals. Now we're going to start applying transformations to this. So we will start with our translations, and the first example is f of x is log to the base a of x plus c. The c is inside the argument, so that's a horizontal shift, and it's going to be counterintuitive, so that would move to the left by c. The second example is a vertical translation when c is outside of the function. Now, for log functions, we typically put our constants first and then the log function so we don't confuse it with the argument. So here, a c on the outside, that's going to shift my function up by c. If c is negative, then it would shift down. The third transformation we'll look at is a reflection. If I have a negative 1 as a coefficient in front of the log function, it basically negates all of your y values. So that means it's going to reflect down. It's going to reflect over the x-axis. Remember, we always reflect first and then move. Finally, we have a horizontal reflection, or a reflection over the vertical asymptote. If I have a negative value in front of the argument, my x values have to be negative to make the entire argument positive. So that's going to reflect across the vertical asymptote. So that will reflect across. And again, when we combine transformations, you want to reflect first and then translate. We usually translate, that's the last thing we do. So here's our first example. I have y is equal to log to the base 4 of x minus 2. The parent function is log to the base 4 of x. This minus 2 inside the function means it's going to shift to the right by 2. So instead of having a vertical asymptote at the y-axis, crossing at 1, 0, and then having a point at 4, 1, everything's going to be shifted to the right by 2. So the first thing I'm going to move is the vertical asymptote. Instead of being at x equals 0, it is now at x equals 2. Now I just contradicted myself because I said you always reflect first, but here we don't have any reflection, so we have to move our asymptote, and then I can graph this function relative to the new asymptote. So instead of having a point at 1, 0, it's going to have a point at 3, 0, which ends up being 1 unit away from the new vertical asymptote. Instead of having a point at 4, 1, it's going to have a point at 6, 1. And then the general shape of the curve will be the same. There's no dilations, there's no stretching involved. This is just going to be the parent function shifted to the right by 2. If I wanted to state the domain and the range, the domain now is going to be x is greater than 2. The range stays with all reals. So we'll do one more for your notes and then we'll practice some more in class. This one, I have a shift outside the function, so this is a vertical shift, and again we like to put it in front. That's -1 plus log to the base 3 of x. So a vertical shift is not going to change the vertical asymptote. So he's still there. What it will do is instead of being at 1, 0, he's shifted down by 1, so he's at 1, -1. So instead of being at 3, 1, he's going to be at 3, 0. So everything shifts down by 1. And that's what he looks like. The domain, this time, x is greater than 0, and the range is still all reals. In class we will practice more translations and also do some reflections and some combinations of the two. But this is just a general introduction to how we graph log functions using transformations.